Okay, the question was we wanted to see a playbook. I'm going to say new Python 3. So what we want to do is bring in two numbers, multiply and print out the result, correct?
Yes, using the input.
Input. All right, let's see. I'm going to say A equals input. Please enter the first number. Okay. B equals input. Please enter the second number. And it should do these sequentially. Does anybody see a pothole already for me to fall into?
You're not taking them as integers or floats, you're taking strings.
He's caught on. It's when I say input, input is going to deliver a string, which may look like a number, but it really isn't. So let's pull something fancy here. I'm going to typecast this to say int. Or tell you what, say float. What's the difference between an integer and a float?
Decimal places or floats.
Yeah, if you want decimal places or not.
Can't that introduce errors if they put in a letter and it tries to convert it to an integer or a float?
Yes. All right. I put in 2 lines of code. Now might be a good time to check it. Nothing wrong with it. So enter the first number, 44. Enter the second number, 88. Okay, it didn't puke. So that's good. Let's test what Thomas was saying. If I say 44 and Fred, what do you think it'll do? So it yarfed. So what we're going to have to do is, it's called sanity checking, to see what it puts in. We have to expect that people are going to put in crazy stuff, and you have to force them to put in something one way or another, either dump what they put in or tell them to re-enter or something. But for right now, I'm going to say print A times B. $77 44 gives, okay, yeah, it's multiplied. And I very quickly multiplied that in my head, and it is correct. Print, let's get fancy. The answer is what's wrong? Somebody catch my goof.
You're trying to combine a string and a float, and it's not going to do that. You're going to need to turn your...
That's a string, right? Also, I'm not using the command right. I've got to put a plus in there. I've forgotten that a few times. So how do I fix my A times B?
You can typecast it to string.
There you go. He's got my answer. He says I can typecast it to string, str. Count your parentheses. Are we okay?
No. One more.
Notice it'll light them up for you if you pay attention. Let's take a swing at this. 22, 5, that's 10. Are we okay with that? Easy breezy beautiful. Okay. Let's jump into some of the stuff from the next couple of sections. Last thing we did was order of operations. Lots of you had done math and understood that just intuitively. The modulus operator, what did we say that was? Returns your remainder. So let's see if we can make that work. And you have to just sort of deal with some goofiness between our book and the newest version of this software. The newest version of this software treats everything like a float. So you don't have the goofs. The older version took everything as integers. So let's just play with it and see. I'm going to say 7 divided by 3 gives me 2.3333333. What do we know it is? It's 2 with 1 left over, right? That's what we're shooting for. So how about if I force it to use integer math? Force. Int 7 divided by int 3. Doggone it, did it. It's going to do it the way it wants anyway. How about integer 7 divided by 3? There's what I was looking for. So it just dropped it. And if I'm not mistaken, it just truncates it. If we say 15 divided by, what can I divide 15 by? 4? What is that? 3 times 4 is 12. Yeah. That gives me a remainder of 3. 3 times 4 is 12. 13, 14, 15. That's 12 with a remainder of 3. If that were rounding, that should have rounded up to 4, shouldn't it? So that just shows that, yeah, the answer was 3 with a remainder of 3, or 3.75. The idea is it didn't round, it truncated. It just chopped it off. So let's say modulus operator. I'm going to say 15. What is that? 4. Put that in quotes just for giggles. There you go. That was my leftover. That doesn't give me the first part of it. It just gives me the remainder part of it. Let's do another one. 7 modulus 3. What should that be? It should be 1. There we go. It cut off the first part of it and just gave you the remainder of the modulus. We okay with that? Okay. String operations, doing goofy things with strings. They give you an example here. Let's just play for a second with the strings. A equals chicken. Print I bought a plus A. Will that work? It'll do something. Does this need to be in quotes? It can be in quotes. It will give me a different answer. I bought a chicken. How about if I did put it in quotes? Syntax error?
No.
I didn't trick you. What's it going to say?
I
bought an A. It took it as a string. When you put it in quotes, it takes it as a string. So it was okay with tacking a string onto a string. Print A times 5. That doesn't make logical chicken. You cannot multiply. It doesn't make logical sense. You cannot multiply a chicken times 5. Chicken. So it actually took my string and just said it 5 times. The man who taught me C years ago had gone to NC State, and all of his examples were chickens and cows. And in his honor, I guess, I carry it forward. And you will learn with chickens and cows. Let's look at this example right here. First equals 100, second equals 150. Print first plus second. what are they trying to show you here?
Written strings. You're adding strings together, you're not adding numbers.
Yeah, they put these in quotes. So when you put it in quotes, that makes it a string. The string 100 doesn't have any relationship whatsoever with 100, even though intuitively you may think that it's supposed to. Throat warbler. Asking the user for input. This is where train comes off the tracks a little bit. We don't use raw input anymore. Because we're using Python 3, it got rid of raw input and it just uses input and it spits out a string. That's the important thing to remember.
I think they updated severance, so like that.
Oh, is there a newer version of
Script.
severance?
No, like the 3 up the top, if you go to the footnotes at the bottom of the page, it gives you the updated for Python 3.
These we've actually done before. One thing we haven't done is this guy right here. The \n.
That just gives you a new line.
That's a new line character. Let's play with it for just a second, make sure we know how it works. Print, I love my \n plus a. What do you think that'll do?
I love mom.
Yeah. It'll drop. I love my. It's going to drop down one and say, I love my chicken. I'm going to leave that there and copy and paste it. How many times can we get away with it? I guess as many as you want to stick in there.
As long as you don't do backslash.
You can't do \\, then it just gives you a backslash.
If you do \\, and the first backslash escapes the second backslash, giving you the actual \n printing out. So you'll see that as text, not as a new line.
Just to kind of, let's see. Print. I love my \n. This is what he's talking about. What's that going to do? The first, I don't need to go over there all the time. The first backslash, this is called an escape sequence. What it effectively means is whatever character follows me, don't take it for what it normally is, the way you'd normally treat it. Do something special. Do something different. That's why we get by with \n. It says \, something special is coming in. Oh, that's a new line. So those two together make a new line. This one I escaped my escape sequence, which made it not be special. So I killed my escape sequence by putting a \, in front of it, which sometimes you will want a \, like if you're going to print out an equation or something. Sometimes you need to kill the special effect of your escape sequence. There are more of them. I don't know how many this supports. Print. Yeah. Yeah. What do you think a \t is going to do for me? Notice that I didn't put any spaces in. Let's goof with spaces. Print. Spaces. \n space. Look and see what happened. There is a space right there. And when it printed it, it put that space right there. So goofing with spaces new line, space at the beginning. It's not a huge thing, but it can trip you up at times. So if I get rid of that, it makes it harder to read in my code. Now what I could do, if I'm just bound and determined to make my code readable, I can do that. And that actually won't be seen because it's at the end of the line. My line now ends with a space. It's not a big deal, just make sure you do what you mean to do. You could look them up and see which all ones support. There can be several different things. \B sometimes will ring a bell. I don't think they support that. All right, here's the big question. Where's the velocity of an unladen swallow? Where did that come from?
That comes from Monty Python Holy Grail.
John raised his hand. He was good and he didn't get to say it. Monty Python. You're not my king. I didn't vote for you. See, you get culture in this class too. Comments. We talked about what a comment was. The only thing that we really didn't hit, if I say $, comment, hello. It just prints hello. Comments are great. Put in too many comments. Comments are fantastic. What you also can do is, sometimes it's handier. Hello. Put your comment to the side. So after your useful code, you can put a space or two and then put a comment. Not every language is always going to let you get by with that. So in some languages, you have to begin the line with that before. But it's handy. And these notebooks are so nice, they actually put it in a different color and make it italics for you. Let's play with this. Print. Ooh, that did not work. The double slash in a lot of things will also work as a comment. So middle note, double slash doesn't work. And I'm going to just kill that so you don't see it. So the pound sign. The pound sign's predictable. When your code is executed, one of the first things it does is pull out all the comments. So don't feel bad about putting in egregious amounts of comments. Choosing variable names, there's all kinds of jokes on the internet and memes about the thing that takes the longest in programming is coming up with variable names. With the stuff we're doing, so that I can teach it quickly, I use A, B, and C a lot. And if it's just a variable that's going to live just for a few seconds or some part of my program, I'll throw in an A or something like that. Anything bigger, give it a decent variable name. And it gave you some examples of just some terrible ones here. What are our rules on variable names? Make it meaningful. That's valid. What are the other ones?
Start with the letter.
Has to start with a letter, can't start with a number. And it can't be a reserved word. You can't make a variable called print. Are variables case sensitive?
Yes.
Yes, they are. Value 1 equals 4. VALUE 1 equals 8. Print. I'm going to be lazy. It's not letting me cut the paste. Dang it. Is TR value 1 plus and plus Q1 is plus AAU1. Did I forget anything? That's a big scrawl of code. Ah, left the space out. I put the space in, make it look a little bit better. What did I just prove with all that? They are case sensitive. Some common methods for making variables make sense if you want to join several terms together. You can say this is the use of bars. There, it took that. It wasn't fancy. I didn't do anything with it. What's that called? That's called camel case. Like a camel's humps, the first letter in every word is capitalized. So if you see the term camel case, that's what that means.
What is that word? Say that one.
Camel, like the dromedary. It would be a horse, but it's got big lumps on its back. That's it. Camel case. And that will help you organize your variables a little bit. It gives examples. It makes your code more readable. I started a complete conversation at work today with this. Debugging, when you're writing code and you're doing, I don't know if this will help. If you're doing some values, it's fine to put a print statement ever so often. Put a bunch of them in there just to make sure that it's telling you at points in the code, is it doing what you think it's doing? The problem that you'll have is this code is beautiful, and I scroll out a page of code and it fails, and then you've got to go back and figure at what point in the execution did it fail. Here's my equation. Was my code screwed up before the equation, or was it screwed up after the equation? Well, I don't know. Put in a print statement, have it print out all your variables, just manually. It looks goofy. But before you submit it, before you do whatever you want to do with it, go back and scratch out or comment out your variables. If it's something that I'm going to have to work on again, maybe anytime in the future, if there's any possibilities, I'll leave those print statements there with a pound sign in front of them, or hashtag in front of them. Just leave them in there. In that case, if I want to screw with my code again, I can just pop those back out and have my debug statements back in. At this level, that's fine. If y'all become coders out in the real world, well, then it still doesn't matter. But you'll probably have an integrated development environment, an IDE, that will offer you better tools to do this with. But for what we're doing, slap in the print statements. And there's our glossary. We've got some exercises. As we go through this, I think Alana came up with this. When the shared directories that are shared between us, there actually are other assignments. Again, it's like 4 questions, and he gives you one of these notebooks, IPNYNB. There's like 4 questions. Those actually are part of the course, so we need to go ahead and be doing those. I won't ding you for the last one because I didn't tell you to do it. But go ahead and do the first one. I'm thinking, again, it should take just a few minutes to do. We'll back up and get that one, and it gives you some more practice. some of the stuff. So where they are, they're in the shared directory under resources, something. We'll find it. I'll come back to it. And those I don't think you actually submit. I think you just leave it sitting there, and I can find it that way. Okay. Conditional execution. What's a Boolean?
True, false. It's
That's
something that's
basically
either
it.
True, false. It's basically like a 1 or a 0.
That's basically it. Trues and falses, ones and zeros. I'm going to show you what's called a truth table. Again, through mathematics, you've probably seen this before. You've got two main operations. You have and you have or. Now, if this were a digital electronics class, it looks like a D, and you've got two inputs and one output. Now, or, you're not responsible for this. I'm just giving you something fun here. That's an AND gate and an OR gate. And you've got A and B and C is your output. So each one of these little lines that I've drawn can have one of two states. It's like a light switch. It can either be on or it can be off, a 1 or a 0, a true or a false. So I'm going to say A, B, C, make myself a table. How many different states can A and B be in? What different combinations can we have? It winds up being 2 raised to the second power, so it's 4. They can both be low, or they can both be false or 0. They can be 1, 0, or 0, 1, or they can be 1, 1. That's it. There's no other combinations that you can have. Similarly, let me do it the right way. 0, 0, 0, 1, 1, 0, 1, 1. 4 states for those. This is and, this is or. And the only time that you have a true output is when what? A and B are high. True. On. Any other, and it stays false. Try to give a real world example. I need a car that will run and has gas in it. If either one of those two tests fail, if it doesn't have gas, it won't go. If I have gas but it won't run, I don't go. If it doesn't have gas and it won't run, it doesn't matter. Okay? The or, 0, 0, if both of them are false, you get a false. But an or, how do you think it's going to work out?
If either A or B are active, then it holds.
That's it. I want a fish sandwich or a taco. I'm happy with either one. If I don't get a fish sandwich or a taco, that's me being unhappy. If I get a fish sandwich and a taco, I'm still just happy. There is a thing called an exclusive or, just for the sake of argument, that a 1 and a 1 would equal a 0.
Yeah, it's the complete opposites of the.
Yeah, they're really complete opposites. So, how are we going to apply this to what we're doing? There's also a negation. And you don't have to pay extra for this, but I'm going to give you the negation. It's that. You just have A and B. It can only be 2 states. You've only got 0 and 1. It negates. And this is called a not. If it's false, not A is B. If it's high, well, not A would be 0. This is where you begin to design computer chips. with lots and lots and lots of these little gates. It's kind of fun. It's just one thing. Look what they've done here. They've done type true. What does the type command do for us? Tells you what kind of data you got. Sorry, John. That's it. So if we say type 4, says it's an integer. If I say type 4.0, what's it going to say? Float. If I say type, it'll tell me what type of chicken it is. String. So if I say type true, what'll that give me?
String.
Yeah, threw you a curveball. That's a string. Notice what the difference was. Here I said type true. It noticed that. It noticed it as a reserved word and said, that's a reserved word. That can't be a variable. That's true. And it's a Boolean. Here I put it in quotes, and then true is just a string. So, how about I say 4 is greater than 2, and 4 is greater than 1. Is that true or is that false? Well, 4 is greater than 2, that's true. And 4 is greater than 1, that's true. And the and, here's my truth table for my and, 1 and 1. What does that give me? That gives me a Boolean of true. And I could have caught that with like A equals if I wanted to, and it would have stuck a true in for A. So how about 4 is greater than 2, or 4 is greater than 1. True or false? True. They're both true. So let's back up and say, make the little alligator go the other way. True or false? Why did it stay true? It's or. Yeah. This fails. 4 is not less than 2, so that's a failure. And I say or, but this is true. So 0 and 1 with an or is true. I'm just going to keep putting these in. 4 is less than 2. And 4 is greater than 1. What do I get? I get a vote for false. Why is it false? Because one of them failed. The text does bring out one term. It's called a short circuit. When this failed, it says 4 is less than 2. That failed. Is there any point, well, it sees the and. That fails, and. At that point, does it matter what that is?
No.
No. Once you force this low, there's no way it'll come on. So, in electronics, an off-on switch, you may have an AND gate, and the A has a switch that just goes to ground. So if you turn it off, it sets one of them low, so it can never go high. That may be kind of a stretched out analogy. But anyway, if you want to force something low, sorry, I'm using electronics terms. False. And. I've created a statement, no matter what I put in here, doesn't matter. I've short-circuited that equation. I can't do anything because that's always going to be false. True. or 4 is greater than 1. Have I short-circuited myself already?
Yeah.
Yeah, I did. I short-circuited myself. That's always going to be true. Why?
That true statement is always going to be true.
I forced it to be true because there's that true, if you look at your truth table, for or, if you've got a 1 in either one of these positions, it's always going to be high. So this second part, it can be true, it can be false, doesn't matter. It's going to be true. 1 and 8 is greater than 3. And 7 is greater than 2. What do we think? You can do a 3-way and or a 10-way and if you want to. The only trick is they all have to be true.
Do you have an and or statement? Or they excludes, or like an and or? Do you have like one is an and one is an or in the same line?
You ask a complicated question. Let's try it and see.
Yes. You gotta put them.
And 8, 3, or 7 is greater than 2. Is that going to be true or false?
Is it true?
Well, they're all 3 true. So if it manages to run, it's going to be true. So it is true. So how about if we force one of these? Yeah, 7 is.
So, like, what's the order in which it's reading this?
That's the point. That's the point to get across on this. This is confusing as crap. You don't know what's going on with it. Which goes with which. So what you can do is this. Throw some quotes in there. Now it makes sense. So I should be able to make that one wrong. So this is false. 8 is greater than 3, so that's the short circuit for this side of the equation. This side would resolve to true, but this is false. So really the only time that I would stack them up, this, is if I were doing this and this and this and this. And then that takes away the confusion. Similarly, I could say this or this or this or this. And as long as any one of them were true, the whole equation would be true. A equals 7. Print. Let's see. Let's keep it. Let's make it more simple. A not equal 4. The exclamation point is your negation operator. So A is not equal to 4. A is equal to 7. So if A is not equal to 4, is that true or false? That is true. A is not equal to 7. True. What number could I put in here to make this go false? 7. 7 is the only number I can put in there. Okay, A is 7. If I say A is not 7, that's a failure. That's false. So that's pretty straightforward. The only real pothole in all of this for you to fall into is if you say A equals 8. Is that true or false? That's a failure right there. Sometimes in other languages that would actually resolve to true. A was 7, and I said A equals 8. And a lot of languages say, okay, I set A to 8. True, it worked. In this, it's saying, no, you're doing something goofy. So your equals, when you're testing if this is equals to that, is a double equal sign. So A equals 1, that's assignment. A equals 1, that's comparison. Does that make sense? And at some point you will forget and say, because just logically from mathematics, you'll say, well, if A equals 1, okay. The last big thing we need to hit is conditional execution. This is where the actual programming starts. Doo, doo, doo. Actual programming. Let's say A equals 4. If, and I'm going to put in my test, if A equals 4, when I hit enter, notice it bumped me in. I'm going to say print, yeah, it was 4. Yeah, it was 4. And this thing will let me cut and paste. Are we sure? Yeah. It was 5. What should I get out of this? I don't get anything because I didn't have anything to catch if that failed. Print. This is another line. What I'm getting at here is anything that is indented after that is going to be seen as part of the first condition. So let's try this. That ain't right. I'm going to force this false by saying A equals 5. A is set to 5. Here's my conditional. If A equals 4, it's going to fail, right? So this should be skipped, and this should be skipped. This is brought back to this edge, so it's not considered part of this clause of code. So what is my output going to say?
This is printed.
It should just say this is printed regardless. Alright, let's get fancy. Else print Number was not 4. I'm just going to slap this in here again. I'm forcing it false this time. A is 5. My condition is if A equals 4. It's going to fail, so it's not going to execute this hunk of code. But this is an else, so it should put in this one and tell you what, just to make it even fancier, print the number was not 4. Another line of code, and then this is printed regardless. Notice this is printed regardless on both instances. All right, let's build on this. A equals 4, B equals 10. If A equals 4 and B is less than 100, okay, that did work. The statement was true. A equals 4 and B was less than 100, so it printed its first part. If I set it to that and run it, the number was not 4. The biggest thing to notice, every language that you come across is going to have an if statement, and they're going to be implemented similar to this. The trick with Python, you've got your conditional, and then you use a colon. You've got an else, then you put in a colon. And that's really the only thing that you have to remember. If I were writing some Python code, I would say, I know how to do an if statement. I just don't know the syntax. So you'd have to just look up how you do it. But this is it. Let's do one more. I hate to do lecture for this long, so we've got a lot of it. It'll give you more time to work. Equals 10. If A equals 4, yeah, it was 4. This is number line. Else, what if I want something if the number was, if B was 10? I can do an elif B is equal to 10. Number was 10. And then logically, we can just say else, colon, print, I don't know what the number was. Sometimes white space makes it more readable. If A equals 4, boom. So there's a couple of things for us to look for if I've not goofed up my syntax. Which one of those things will print? It comes to here, if A equals 4, does A equal 4? Yeah, that's true. So it will print this. Okay, if we go to the next statement, look, if B equals 10. Well, yeah, it does. So this one's true as well. Is it going to print the number is 10? And then else, I don't know what the number is. We really shouldn't get this because that's not true. The first two are true, that one's not. And then finally, this is to be printed regardless. Okay, so what happened? It's printed two lines, which are these two lines. So the thing that we need to highlight here is once it found something that satisfied a true statement, it stopped. It jumped to the end of the code. It skipped that elif b equals 10. Now let's see if we can. I'm forcing the first condition to be false. It's false because A is 4. So what do you think will happen?
The second statement.
It's going to print that second little hunk of code. The number is 10. And let's do one more just for giggles, just to prove it's doing what we think. What should that do? It should put, I don't know what the number was, and we should get our, this is printed regardless.
So what does elif mean?
Else if.
Else
And you can chain these. You can say, if this, okay, else if this, else if this, well, else if this, else if this. And then your final else is going to be a catch-all. That if everything else failed, this is just going to catch whatever the condition is. So I made this notebook extra special big with the intent of I'll post this to Moodle. So it can kind of serve as notes for y'all. It may help you to, I remember doing this in class, what did we do? That sort of thing. So I'll try to be conscious and not delete it or not wipe stuff out. Let's see if this recorded. It is.